So this is H350. I had this, I have purchased this stove about 2 years ago and already have some problems with it. So when I click the power on, I can hear some rumbling and my door is open, so we're not going to expect the fans to turn on, but when I click ignition air, the fans should turn on, but the fans do not turn on. So that's the issue that I'm seeing here. Let's try to figure out what's happening. I would assume that the fans got stuck for some reason, and the fans are located up in the front over here, so we're going to be taking off this panel off right now. There's the screws here that I have already actually took off on all of those sides, so the whole thing will come off right now. Let's have a look what's inside. Actually, there might be some screws under. Yeah, there's some screws under here. So 2 years in use, I do see some sort of residue on the inner panel here. Not sure what this is all about. Looks like some dust came in. This panel just lifts off like this. Let's set it aside over here. Now we can see the air intake right over there. Definitely, I'm not sure, we'll have to take it apart further to see what's inside. Now to open it further, we're going to need to take this and set it up upright, and we'll just push it open. Just like so. So let's see what's happening in here. I'm going to try to power it on and we'll see what's going on. So before we turn this on, I want to just show you quickly what we're seeing here. These are the caps that let the air in when it's open. It allows the air to flow inward. And on this section here, we have a fan that blows air from the outside into the fan blades over here, and then it forces air into here. It creates a region of high pressure over here, which in turn blows the air into the holes over here, and the holes then channel the air inside into the actual stove. Okay, that could have been just calibration. The fans are not turned on, that's proper. That's what you should be seeing. Let's turn on the air. I can definitely hear high-pitched sound that is coming from one of the servo motors over here. That's fine. So one thing about servo motors, you can actually force them to move up higher, like this. Okay. Oh, I can see a lot of black residue inside. That's not good. I have to get a flashlight and shine into it. Okay, so what I want you to see here is the amount of the creosote that gets accumulated inside the holes over here. Cannot really see even the entrance really, so it really needs to be cleaned out. and this is an intake into the main chamber. So I think something is definitely not right with this, because it shouldn't look like this. Okay, that's the upper one. The lower one, however, is all good and clean. So I guess the lower one goes into the secondary combustion, and this is the primary one. That doesn't look too good. Okay, so presume that this is a starting point. Now I'm going to simulate the door closing by pressing this right here. Okay, I can hear high pitch sound from the motor over there. It's trying to open it very slowly. Now it stopped doing it. And that's pretty much it. That's what we get here. Now the wire from this this motor over here, from the stepper motor, it comes into this socket over here. So I'm going to take off this connection here, and I'm going to put it back in just to see if maybe it's a connection issue or something. Okay, I've put it back in, and let us simulate the door opening again. I mean door closing by pressing the switch here. Okay, that went well. It opened a little bit more, but the fan is not going at all. Talking about this fan over here, it's quiet like on the Western Front. Okay, so let's try it again. Okay, opens a little bit better. Okay, so I moved the I unplugged it, I wiggled the connection, I wiggled the second connection here, and I also unplugged and plugged in the main fan assembly here. Nothing seems to work. I see that there is another connection right over there, so I'm just going to try to wiggle that one back and forth, see if that's going to help. Come on. This one's a little tight. Yeah, going to plug it back in. Yeah, I can definitely hear how the high pitch sound from the servo motors over here. So I'm going to simulate the door closing, which should trigger the upper cap to open. I'm not sure if it's supposed to open that little. I would expect it to go a lot higher. This guy is supposed to start, but it doesn't. Maybe this needs to go all the way up. So I'm going to just, it's very difficult to move the motors up because they are very powerful things. Yeah, almost there. Okay, this is as high as it will go. You can actually see the creosote that comes from it. Really bad condition, I would say. But that should not be the core problem for us. This thing should be working. Now we're going to simulate the ignition. Force air. You can see that this thing opens up just slightly. Actually, this thing is actually making sound. It's vibrating and it's cold. It's hot. So this guy is stuck. Okay. we need to turn this thing off. Okay, we know the culprit. This guy is bad. Why is it bad? Why is it not spinning? Yeah, it's definitely hot to the touch. I'm going to need to disassemble this one over here. It has only 2 wires coming in, so that's good. It's going to be easier to diagnose, and we'll see what's up with the fan unit. Okay, to take this fan off, there's 2 screws over here that we need to take out, and I don't see any other place that it holds on to. Okay, it's out. So what are we going to do next? I'm going to find something to rest it on, and we're going to unscrew the top portions. Actually, before we do that, let me see if the blades are stuck. Oh, they spin quite well. They do spin well. That's strange. They're not stuck. You can see that I give it a turn and they spin all by themselves. Okay, so they're not stuck. Okay, the power is on. This thing will calibrate themselves to the close position. Okay, this thing is not going to turn. We know that from experience. It's not going to vibrate because we need to make sure that we simulate a door closed or this air on. Whoa. It's working now. Okay. So I guess it was stuck. Okay. So this turned off. So it started to work. So what am I going to do right now? I'm going to put this thing back together again and just hope that it's going to continue working for me. Definitely going to share this video with the company, whatever it is. What's the company name? Heatmore, I think. No, Central Boiler. Yep, I'm going to share this info with Central Boiler. See what they say about it. One thing that I did notice with Central Boiler is that they also have a sensor over here inside of the panel, flotation sensor that tells you if your tank is full of water or if it's overflowing or if it's underflowing. If there isn't enough of water and the flotation sensor triggers that there is not enough of water, it's supposed to shut down the whole stove so it doesn't overheat. But that flotation sensor gets damaged, and I'm not the first one. From what I heard, basically the plastic melts. They used to have metal flotation sensors, but then they switched them to plastic ones, extremely cheap plastic sensors, which did get damaged through heat. And then from what I heard from the dealer, they switched them back to back to the metal ones, but I went in and I just short-circuited that flotation sensor, hoping that my tank will not leak, and going to replace it down the road, but right now I didn't have enough time to do that. Another thing that I've noticed with the stove here is the gasket. The gasket does get burned and scorched. I talked to the dealer. They told me that they do replace the gaskets. Well, you do have to replace the gaskets every few years, and I think that's just a bad idea. You see how they have them rubber? They're made of rubber. Yeah, it's definitely a rubber that can sustain heat for sure. I mean, they wouldn't ask safety and compliance testing if it wasn't a heat tolerant rubber. But the point is, this probably shouldn't have been rubber. It should probably have been fiberglass, just like what they have here in the secondary combustion chamber. You see, that's what they have, fiberglass. That's what they probably should have had at the door over here, to prevent it from being burned. And dealers have to go out and replace the rubber gaskets to people. They charge extra for that service. I guess if they had fiberglass wire or rope that they have here, they wouldn't need to go out to their customers as often, and consequently would make less money. So that's the deal. Not everything is awesome. You do have to keep an eye out on things. Okay, so what else am I going to do today? I'm going to actually take this whole mechanism off, and I'm going to clean inside. You can see that this section is all rubber. It looks like metal, but it's actually rubber. So I'm going to take off the rubber boot over here, and the small stepper motor sits right on top of it. So once I unscrew the screw over there, the whole thing should come off, and I'll be able to clean this guy and the inside of it. Let's get that cleaned up. Just about any screwdriver will work for this. I do have a chainsaw tool that I use, and it should be fine. It comes off fairly easily. It's not very tightened, not as tight as I would expect it. So a couple of more turns and we'll be able to rip this thing out of here. Oops. Okay, should be able to remove it now. Move it back and forth. Oh, I can feel it's very dry. Oh my. Let's have a look. Whoa. A lot of creosote. Good that we removed it. Okay, let's have a look at what's on the inside now. Again, you shouldn't let things hang from that by themselves like that. Just so it's a log stove, meant to burn logs, so we can use a log to support our high-tech stepper motors. Okay, let's have a look at what's going on inside. Doesn't look very nice. Let me shine some light in it. I'm not even seeing a hole over there. Actually I am. Just a tiny one. Definitely need to remove all of that junk. Check out this piece. It's huge. Probably would burn well. Came right out of that hole. But you know what I'm worried about? I'm worried about that inside of it there's a lot more of creosote within the cavity over there, which was never burned. And if that's the case, it might be blocking additional holes. So there could be only just a few holes that are left open, and the rest could be blocked up by the creosote. So I've scooped out as much as I could, but there is still a lot of it there. So I'm going to try something drastic over here. I want it to be burnt out or removed somehow, and I'm going to light up a fire right inside the hole, and I'm going to blow some air into it in hopes that it's going to burn the creosote within the cavities over there across all of the inside portions of the stove. You know what? I have devised another plan over here. I have separated this thing and cleaned it out as much as possible. I also cleaned out the inside of the rubber element as well. I want to see how much air is actually getting through that hole and how it gets distributed across different holes over here inside of our tank. So this is a mullion, dry mullion stock. I'm going to flower stock that I'm going to light on fire on one side. It's going to start smoldering, and the idea behind this mullion is that the more you blow on it, the more smoke it creates, and the less blow you on it, the less smoke it creates. So we'll be able to gauge how much airflow is getting through all of those holes inside of our stove. And there's one hole over there. There's another hole over here. So the smoke will be a little bit difficult to see. That's why I decided to bring in some light. So I did find the last hole over there, but I actually had to drill it out because it was all stuck with creosote over there. So now we can light up our torch, our mullion, and see how the smoke propagates. But before we do that, I actually need to close this thing so there is proper airflow. Now the airflow will be a lot higher than usual, simply because the hole is open all the way through. And we're going to close this section over here so that everything is creating the proper pressure that it should be creating. So it creates smoke, but when you blow on it, it will create more smoke. Let's test the ones on the very ends. You can definitely see it lighting up and smoking. That's good. This one, really creating a lot of smoke. This one's really good. That one, yeah, that one's really good. Let's go to the one that was stuck. Yep, there is some airflow there as well. This guy, really good. The ones over here, also really good. Looks like there's only 2 holes over here. 1 and 2. Let's see if the second one is working. Yeah, it's working. Okay, looks like everything is working. So the only thing that concerns me is that there's still a lot of creosote inside of those pathways, and I think it's a good idea to burn it out. And we're going to burn it It's going to create a lot of heat. And I think if we do it properly, and if the system is built to take on a little bit of heat inside of the inner channels, I think we should be able to clean it up really well. Let's give it a shot. Okay, attempt number 1, we're going to place mullion inside, and let's see if it's going to work. It does not generate usually adequate amount of heat. Yeah, it wasn't a very good idea. Looks like the mullion is all gone and it didn't ignite anything. So we'll need to actually introduce some embers inside. Okay, a couple of coals. I think we're ready to go. Let's have another try at this. Some ignition air. It's starting to burn. Maybe I don't even need another piece of coal over there. Maybe that's going to be sufficient. I'm going to close it up just a little bit. I'm going to start igniting. And let's close it out quickly. Yeah. Now it's really burning. I think the plan is working. Hopefully the creosote will ignite inside of those pathways, and it's going to burn up just like that. I'm going to put video on pause right now, and we'll see what happens. Definitely a lot of smoke coming out, and I can see the sparks flying out. I'm sure this is not just those couple of coals that I put in. They wouldn't be able to generate that much smoke. It's definitely creosote burning up, and I can sense the smell from it. It's very distinctive. So a lot of creosote accumulated in the air pathways that needs to burn up now. Okay, a lot less smoke, about 1 minute after I post the video. A lot more sparks flying out though. We're still seeing sparks coming out, but they're shooting out from the 2 holes. I'm not seeing any sparks coming out from any other holes right now. So I'm not sure if that's going to be, if the fire will propagate its way to the other locations. I'm actually thinking that I might need to close the 2 holes and allow more air to flow to the other sides. Let's look at what's happening inside. And it's burning its way to the other sides now. And I think it's going to work out well. We'll see what happens. Definitely we cleared out what was. So each story has a beginning and each story has an end, and I think we have come to the end of the story. I was able to remove the creosote within the first section over here, which is right by the fans, but I wasn't able to remove creosote within the other deeper margins, deeper pathways. I'm not exactly sure how to get them to them, and quite frankly I don't care at this point because I'm still getting airflow through them, so I'm just going to keep it as is. At this time I'm going to be assembling back everything together again, attaching the this guy back there, and that would be it for today. Thanks for watching. Hopefully you found this informative. I do not recommend this method to anyone because, as you have seen, it's not a very safe method, and I have no idea what consequences, long-term consequences of this is. So that's pretty much it. Inside over there is clean. Everything did burn up within the first chamber, and we'll see how the stove performs in the new season. Take care.